Peter Hahn, ladies and gentlemen.
Thank you. So, hi everyone, I'm Peter Horn, I work for NI. I actually came to uni in Brighton, so I know a few fun facts. Fatboy Slim's from here, if anyone's into dance music. Did a big beach on the, big gig on the beach 20 odd years ago that I went to. It was quite fun. Anyway, so I wanted to start off with Our Giant's a Female. As James was saying, it's kind of become customary. I was looking for interesting, inspirational people to talk about, and found out about this lady, Sheridan Ash. She was named named the UK's most influential woman last year in tech by some panel. Driving a lot of technology initiatives to help kind of the government and businesses realize how to use technology to solve large-scale challenges. One of the most, or the interesting things that I felt made me want to talk about her was the fact that she has got this Tech She Can charity that she started to deliberately try and inspire young people, especially women, to get jobs in technology and trying to kind of help them see that technology is not a male thing. Women can be just as good and do just as well in a lot of areas. So it's a massive organisation. There's, I think, about 240 member organisations that she works with across the UK and globally. So she's doing quite a lot of good there. So I wanted to talk about some graphic stuff that I've been working on over the last sort of year or so. Kind of started in a conversation at last year's GDevCon with Olivier. Quick show of hands. Has anyone here not used or looked at Antidoc at all? Anyone not familiar with it? There's a few hands up. Find Olivier, go and talk to him. Antidoc's awesome. Olivier, so, are you here? Here's Olivier. Talk to him at coffee, or buy him beer tonight, and then he'll run less fast in the morning. So I'm not going to go into details about Antidoc, but Antidoc uses a tool under the hood called AsciiDoc to do a lot of the diagram generation. And being kind of nosy, curious, quite kind of the same thing, I started looking at AsciiDoc and some of the things that could do. And I got to this website, and it's got all these different plugins. And I was looking through them and came across Vega. And I went onto the Vega website, and I think I've got it loaded over here. Oh no, that's not worked. Why's that not worked? Never mind. The Vega website, you can see all of these different graphics that Vega can generate, and it's basically just a JSON configuration that you give to this binary, and it generates an image. And I kind of thought, wow, that's really cool. There's some really cool graphics there, kind of far, not necessarily in advance of what you can do in LabVIEW, but definitely different to what is available out of the box in LabVIEW. And it'd be kind of really cool if we could build some of that into LabVIEW and have some of that capability, because as you can see here, we've got maps of the US, and we've got these spider diagrams. There's loads of things there. If you had a data set that matched one of those types, there isn't really anything available in LabVIEW to be able to do that. So I kind of thought, let's have a play around and see if I can get some of that to work. So the first thing I did was just make a bit of a proof of concept. And this is the proof of concept running. You can see that the JSON file on or the JSON script on the left. I've just generated random numbers, and in this configuration, there's an array of data there that I'm passing into it, generating a different set of random numbers every time, and they're being plotted onto this radar plot here. The little graph at the top is just how long it's taken to generate each one. So it's not super fast, and I'll talk about that in a little bit. There's some shortcomings with the way it's currently doing this that I'd like to try and resolve, but it works, so that's kind of cool. Or this worked, and that kind of inspired me to take it further a bit. Just to quickly show the LabVIEW code, it was a proof of concept, so it's complete rubbish code, but it did work. There's a JSON, or a JSON object or string there with just using the formatting string function to put random numbers into it. The interesting bit is up in the top right there, where you can see I've got that little function, I can't remember what to call it, render JSON or render file. That is taken in the JSON string and going out to the Vega binary, generating a PNG file, saving the PNG file to disk, and then I'm using the 2D pitch control toolkit to stick it on the front panel. That it works, but that whole idea of saving a PNG file and then using the 2D pitch control is not exactly a nice way of generating data to go onto the UI. So that's definitely one thing that I want to try and improve. If you're just generating the PNG file to go into a report, then that works fine, and as it is great. To start off with, though, I've kind of left it with that, and I've concentrated on trying to make the configuration of the JSON strings a lot easier, because you can see it's a pretty complex JSON object there. I don't know how many options there are for configuring different parameters and stuff in Vega, but you can either have the data coming from an object or a set of data in the string there. You can have it coming from file. You can have different types of plots. You can have all the coloring. There's thousands and thousands of different options. And some of the parameters that you need to put in, I found were not necessarily super understandable. So I wanted to kind of try and avoid having to write out the JSON script myself manually every time I wanted to generate one of these files. So I started working on an API to make the generation of the JSON a load easier, and then figured I'd kind of get to the putting it on the front panel in a nice way a bit later on, possibly with some help of other people. So I started working on an API. You can see here there's still places where you can add in custom JSON if you know how to specify a section in JSON, or if there's no API for developing that part of that feature yet, then that's totally cool. And I've left bits in where you do still need to add in custom JSON. But then there's a lot of places where I've created override classes, so you can specify things like the axis and the colors of the plot via just sort of property nodes or methods in the classes, and it creates the JSON string for you behind the scenes. And then this render block down here on the right-hand side is doing exactly the same thing as I was doing before. It's just in a sub-VI now where it's writing the data to a PNG file, and then the path to that PNG file is stored in the class private data. So yeah, that sort of shortcoming is still there. And so that works fine. You can see a couple of different plots here. Bar plot on the left, sort of error bars on the right, and changing some of the properties around. And yeah, like the background color, I added in things like you can set the background color to just take the background color of the VI that it's working with to make it a bit more, sort of blend in a bit more, but yeah, it's not super complicated. So next steps or things I would like to improve. As I mentioned a couple of times, I'm definitely I don't have all the ideas on how to take this to actually making it into a really good toolkit for general use, and certainly not for getting the data onto the UI in a slightly cleaner way. So if people have got ideas and are interested, I'd definitely love to talk to people about it. There are a few bugs that I know of in there, and I'm sure there's plenty of bugs that I don't know about in there at the moment. One bug that I do know of is that it seems to throw a bit of a hissy fit if the repo is cloned to a drive that's not C, because I tried to clone it onto a VM that had a big D drive, and it didn't really like it. And I think I know sort of why, but not entirely sure why. I'm sure there's other bugs as well. There's also things that I'm not too sure of if I've done them in the right way and would be, and I'm sure the general quality of the code could be improved. The bottom three, I feel they're the improved speed, the graph types, and the interactive elements. I'll talk more about the interactive elements in a minute. But they're kind of a byproduct of the fact that I'm doing that two-stage operation where I'm going from generating the PNGs on disk, and then putting that onto the UI with the 2D pitch control. That's obviously a bit of a slow process, and I think it could be speeded up by just having that going directly onto the UI. And so actually, additional graph types is just I haven't implemented those, so that's nothing to do with the PNG file. Yeah, the speed could be improved with that. And then the interactive elements, you can see here on the right, there's these two that were I took them off the website. And you can, although it's an element on the UI, it's a bit like an X control, I guess, where they've defined this kind of auto scaling into it. Someone's even written a slightly rubbish version of Pac-Man in Vega that you can go online and play it if you want. And it's a good way to waste an hour of your life is playing a rubbish version of Pac-Man online. So I found that out. So yeah, having that is quite cool, and I think that'd be quite interesting to implement. But obviously, that doesn't work with the API as it is at the moment because it's just a picture. Additional graph types, you saw on the screenshot of the Vega website, and I couldn't scroll down because I didn't actually have the website open, but there's hundreds of those graph types that have been created. Some of them, like Pac-Man, is probably completely irrelevant and useless to this crowd. There's a lot in there that I think would be really useful to a lot of people. And so it'd be good to add in more support and make more of those accessible. In theory, any of them could be generated by, if you just have the JSON string in your LabVIEW code, send it to the binary, it'll generate the PNG file, and you'll be able to put it on your UI, and that will work. But obviously, having the ability to do it nice and easily is something that's good. So yeah. Okay, so that's kind of everything that I wanted to talk about. So it's a bit of an intro, a bit of a whistle-stop tour, similar to James's, of what I've done. I'd like to, if anyone's interested in it, I'm totally open to talk about it. I will put these slides, I'll send them to the Discord channel or something, so the links hopefully will still work, and you can look on the Vega website. I put a link to my LinkedIn there if anyone wants to talk to me afterwards, or peter.horn@emerson.com. Feel free to send me an email. The GitLab repo is there as well. As I say, if you don't know Antidoc, go and talk to Olivier. That's an awesome toolkit. Cool. I think I've got 5 minutes left a few minutes for questions. Anyone have any questions or thoughts at all? In the middle? Yeah. I think it's just Mike coming over.
For Vega, HTML was also an output option.
Mm-hmm.
Okay. So
yeah, I think, if I remember rightly, HTML, SVG, and PNG, I think, are the three options. I've just been using PNG, but you could point to the other binaries as well. It's a separate executable file on disk that you pointed to.
And with the HTML, we would get interactive functions, I think.
I think you probably would, yeah. I haven't played around with it a whole lot, but yeah, I think you're right.
Thanks for the nice presentation.
Okay.
I'm here.
Yeah.
I was wondering, did I get it right that you are basically writing the file, the JSON file to disk, and then call a command line tool, or are you interfacing directly to the library somehow?
So I've got the JSON file, JSON string as a LabVIEW string, and then the VI package that Olivier helped build calls I think it's called vector to PNG. It's an executable file on disk. So we call that executable. Yeah, we call that executable and pass it the JSON file.
Does this library also have some direct interface, like a shared library interface?
I don't think so. I think it's
Okay.
just an executable with a command line. I'm not sure, Olivier, if you know.
No. Okay.
Yeah, thanks,
Yeah.
Peter. Here, Peter.
Mm-hmm.
Yeah, thanks for your presentation. I figured out that the 2D picture control has a big performance penalty using PNGs, and I switched to simple bitmaps because they render much faster. You could also try this.
Okay. That might be worth a try. Thanks. Yeah.
Just to add to the question about how you can get the picture. You are using the command line interface, basically. Yeah. But it's possible to get the HTML version and have all the interaction with SVG embedded in the HTML file.
Okay.
So there's a lot of possibility to get the picture, and as you said, the question is how I can integrate it in the UI if we want to use it in the LabVIEW application.
Yeah, makes sense. Thanks. Good. Another question in the middle there.
Thanks for the presentation. I find it really interesting, but I'm interested in performance. Have you tried it with benchmarked it with large data sets, and how fast approximately have you been able to make it run?
So I haven't done huge amounts of benchmarking on it. Roughly speaking, it's, I think, executing at about I think it was about 700 milliseconds to generate an image. That is honestly quite a simple image. I'm sure if you gave it a much larger data set and asked for a much bigger image, it would probably take longer. But at the same time, I was executing on a fairly small VM and things, so I'm sure you could give it a higher performance system and it would execute faster.
How much time have you said?
It's about 700 milliseconds, I think it was. So, yeah, a bit over once a second.
Okay, thanks.
Okay.
I believe your best call to improve speed would be to use the HTML rendering and display that in a web view control directly. So you would just display pure HTML. It's because definitely generating a PNG picture, it's probably the slowest option.
Yeah,
that is available with Vega.
Yeah, I'll have to try that out. Thanks. Okay, I think I don't see any other hands up. So, one more down at the front.
Yeah, so next to this toolkit, you can also use Mermaid, but that's more oriented to UML diagrams. But
yes.
It's pretty much the same. It doesn't use JSON. So if you have more time to experiment, you can extend it to all the other options that are there in the or the open source community can do that.
Sure, yeah. I've played around with Mermaid a fair bit. I've not tried putting it in LabVIEW, but I've done bits and pieces with Mermaid in the past.
Shameless plug, if you are using ASCII-Doc toolkit, you can use Mermaid syntax or all the diagram syntax Peter showed at the beginning of his presentation and create PDF or HTML using with all these pictures.
Cool. Okay, thank you very much. I will let you get to break.